Hey, so we're talking about graphing polynomial and rational functions. So what are we interested in? When we look at a graph, there's some features that we're interested in. We're interested in where it's increasing, decreasing, and increasing. We're interested in these peaks and valleys. We're interested in the zeros. We're interested in where it's concave down and concave up. So we're going to use what we know about derivatives to find out all of these things. So, first, notice that wherever our function is increasing, what is it doing? If it's increasing, it's going uphill. So I'm increasing right here. Where else am I increasing? I'm increasing over here on forever. My function is increasing. Okay? What do I notice about the other places? Well, from here to here, what's happening? I'm going downhill. So I'm decreasing. If we have the graph, that's pretty easy to tell. But what if we just have an equation? How do I figure out where is it increasing, where is it decreasing, if I don't know how to graph it? And so there's an interesting thing that we notice here. Along all of the places where I'm increasing, let's look at the tangent lines. If I look at all of these tangent lines, what do you notice about all of them? What you should notice is they all have a positive slope. Where I'm decreasing, what do you notice about the slopes of the tangent lines? What you should notice is they all have a negative slope. Well, how does that relate to a function? How is tangent line, slope of the tangent line, connected to the function? Well, it's connected by the derivative. So the slope of the tangent line is equal to the derivative of the function. So what does that mean? It means where my function is increasing and I have a positive slope, my derivative is positive. It means where my function is decreasing and my tangent lines have negative slopes, my derivative is negative. Well, that tells us something interesting. If my function is increasing where there are positive slopes, positive derivatives, and decreasing where there are negative slopes and negative derivatives, what happens at these peaks and valleys? That's where my derivative is equal to 0. Those are going to be special points we're going to talk about later on, and they're called critical points. But they're the points where the function changes from increasing to decreasing, or where it levels out and is flat.